Hey guys, so this is your FRQ helpful hint video for the week of 113. And this is problem on page 54, FRQ 2019, and we're going to be doing questions A and B. Okay. So let's go ahead and take a look at these. This is a rate of change problem. What do they call those? They call them related rates. So we have a cylindrical barrel with a diameter of 2 feet, and it's collecting rainwater. And as you can imagine, as it does that, the height of that rainwater is changing, and the volume of the rainwater inside the container is changing. The water drains out through a valve, which isn't shown at the bottom of the barrel. The rate of change of the height h of the water in the barrel with respect to time is modeled by this expression here. So this is Dht, where h is measured in feet and t is measured in seconds. And then they tell us what the volume of a cylinder is. It's this. So keeping all that in mind, let's take a look at A. Find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate the units of measure. All right, so the way that we did this was we drew a picture. Now they've already given us a picture. Okay, so we don't need to draw a picture. The next thing that we did was we identified the rate that we want. The rate they're asking for is dVdt, the rate of change of volume with respect to time. The next thing we did was we identified our units. So volume is going to be in cubic feet, and our time is in seconds. So this is going to be in cubic feet per second. Okay. After we did that, we don't know what that is, but once we get that number, we want to know our units. We identified what the given rate was. Now, they kind of gave us a rate. They did and they didn't. What they did was they gave us a formula for the rate. So it's negative 1 over 10 square root of h. So they kind of gave us our rate of change of h with respect to t. The next thing that we did after we identified our desired rate and our given rate was we looked for a formula that connected volume to height, which they've already conveniently given us. So there's that. Okay. The next thing that we did was we found the derivative of this expression. Okay. Now, but before we do that, there's an extra variable here. It's r, but it's not really a variable. R stands for radius. And in this problem, does the radius of the cylinder ever change? The answer is no. The radius is always 1. The diameter is 2, so half of that is 1. So the radius is always 1, which means that we can simplify this little formula they gave us by writing it like this. That's really nice, actually. That makes this problem way easier. So there's the good news, is we didn't really need to do anything with the r other than just plug in 1. Now, anyway, so we take our formula, and now we take the derivative of it so that we can use the derivatives over there. So the derivative of v with respect to t is equal to pi, which is a constant, so it just stays there, dH dt. Oops. Now we plug in what we know. We've already admitted we don't know what the volume is. Pi is just a number. And now we're going to plug in dH dt. Well, according to the problem that they gave us, we need some space over here. We know that dH dt is the following. It is negative 1/10 square root of h. Okay? Now, we still need to get rid of this h. Once I know what h is, I can find the rate of change of the volume with respect to time. Well, they told us we are trying to find the rate of change of the volume when the height is 4. So we just go ahead and plug in 4 there. I'm going to multiply pi times negative 1/10, and I'm going to plug in my 4 here. Now the square root of 4 is 2, so now I've got this, which reduces finally to this. And as we said, that was in cubic feet per second, I believe it was. That's the rate of change of volume with respect to time. So you will see related rate questions on your free responses. This was actually last year's free response question. So that's a 5-step process you go through, and good thing to write down on a flashcard and keep practicing every once in a while to keep it sharp. Okay, for question B, pretty interesting question. It kind of stumped me a few times when I was first looking at it. All right. When the height of the water is 3 feet, is the rate of change of the height of water with respect to time increasing or decreasing? This is a really crazy sentence here. Rate of change of height of water with respect to time. Now, there's a much easier way to write that, and it's Dht. Okay? That's the rate of change of the height of the water with respect to time. So, when the height equals 3, is this increasing or decreasing? Well, if you want to know if anything is increasing or decreasing, you need to find its slope. Okay? If the slope is positive, then it's increasing. If its slope is negative, then it's decreasing. All right, so I need to find the slope of this. So I need to find the derivative with respect to time of dH/dt to find out if it is increasing or decreasing. dH/dt is negative 1 over 10 square root of h. Now this is a constant multiple, so when you apply the derivative here, the constant multiple is going to stay the same. It's going to be negative 1/10. But it will affect the square root of h. That's going to be 1 over 2 square root of h. But notice that this variable doesn't match this, so we need to multiply it by dH/dt. We need to multiply it by an h prime. Okay? Which means dH/dt is negative 1/10 square root of h, right? We have that earlier. So I can just replace this with this. So you end up with that expression within itself there. So let's go ahead and simplify this. First of all, the square root of h cancels out. The negatives cancel out, and we're left with 10 times 2 times 10. So the final answer for that one is 1 over 200. Okay, so the question was, when the height of the water is 3, is dH/dt increasing or decreasing? To answer that, we found the slope, or the derivative of dH/dt, which was a chain rule, so you end up having to multiply by dH/dt after you take the derivative. And it comes out to be a whole number, or not a whole number, but just a number without any variables. So what that means is no matter what the height is, usually you would plug in height equals 3 at this point to find out whether it's increasing or decreasing. But since there is no h in this problem, then that means the rate of change of dH/dt is always 1 over 200. Doesn't matter what the height is. And that's a positive number. So since it's a positive, that means it's increasing. But something that I want to point out to you guys here on this problem is how to do your explanation, because it does ask for an explanation, and on these problems the explanation is a lot of times most of the credit. So when you give an explanation, your answer needs to have a context, an input unit, and an output unit. Okay, so here's the context. The context is, that just means what's happening in the story problem in this explanation. So you have to include this. Your explanation should include, it's like a complete sentence, in other words. You can't just say, it's decreasing. You need to give a context, what's going on in this problem. So here's what's happening. The rate of change of height with respect to time, I pretty much just plagiarized that from right here. the rate of change of height with respect to time is increasing at h equals 3 feet since the second derivative, which is the derivative of the ddt, came out to be positive. So here's my context. The rate of change of the height with respect to time is increasing. That's the context. Here's my input units. I plugged in 3, not really because there was nowhere to plug it into, but there it is. Since the second derivative is 1 over 200, which is positive, there's my output. So a good explanation will have those 3 things in it, and that's how they grade you on these. So let's go ahead and take a look at how they would have graded these. On the first problem, you'll notice that they wanted to see the derivative of your formula and the answer with units. Notice in particular on number 1, I'm sorry, the second part here, that the answer has to be with units. In other words, you can get the right answer, but if you forgot your units, then you actually lose that entire point, which is pretty sad. So when they say include units, include your units. For the second one, here's all the work that we did. Here's their explanation. Because the second derivative is 1 over 200, which is greater than 0, the rate of change of the height is increasing when the height of the water is 3 feet. And there's their explanation. So that was 1 point with those 3 contextual elements. They wanted to see that you basically just did the derivative correctly. I don't know why they decided to give a point for this, but we'll take it. Oh, they did the derivative with respect to h first, and then they did the derivative of that with respect to t. I'm going to sit out explaining why that is. I think the way that we did it will be good enough. But anyway, that would, our derivative would have been worth 2 points basically. All right, moving on. Okay, guys, so for the next one, which is on page number 60 in your guys' book, we're doing question B. It says, find the rate of change of the volume of the balloon with respect to time when t equals 5. I'm going to go ahead and let you guys try this one on your own. It's a lot like part A for the last question that we just went over. So go ahead and try to work it out on your own and look up the answer key and see if you get it right. Okay? I'm going to go ahead and move on to the next question. All right, guys, so number 3 on page, and look up what page that is. It should be on page 72 in your guys' book. We are going to be doing letter D, I mean. Okay, so let's read the problem. Hot water is dripping through a coffee maker, filling a large cup with coffee. The amount of coffee in the cup at time t, from 0 to 6, is given by a differentiable function c, where t is measured in minutes. Selected values of c of t, measured in ounces, are given in the table above. So basically we have water dripping into a coffee pot over a 6-minute period, and this is how much coffee would be in the pot, I guess. Now they tell you that it's differentiable, which means there's a derivative of it, which means it's also continuous. But actually all of that's unnecessary for the problem that we're looking at. On part D, they create a new function. The amount of coffee in the cup is modeled by this. So now they create a new function for us, and they say that that's B. Using this model, so in other words, we're probably not going to be using this table very much because this is about the function C, but they've given us a whole new function. But at least we know the story now. We're talking about water dripping into a cup or something. So we have this function. So that tells us the amount of coffee in ounces in the cup after however many minutes have gone by. Now they want to know, using this model, in other words, using this equation, find the rate, okay, in other words, the derivative of this thing, at which the amount of coffee in the cup is changing when t equals 5. Now it doesn't say to include units, but you better, because we're doing a word problem and units are there. So I would not skip out on the units, okay? So basically what you guys need to do is you need to find out what b prime of 5 is. That's it. So you got to find the derivative of that expression, and you got to plug in 5. The one thing that you might get a little stuck on here is how to find that derivative. So I'll give you a quick example for you. Let's say that I had e to the 5x minus 3, right? And I'll put a 2 in the front. And I wanted to find the derivative of that. Well, anytime you have an e function, well, back up a little bit. Constant multiples don't change, so that 2 just stays there. And anytime you have an e function, that also just stays there. It doesn't change when you take a derivative. But you do take the derivative of the actual exponent. The derivative of that exponent is 5, and that, you're going to multiply that to the front. So this would be the following. You're going to need to be aware of that as you do this problem. But that's basically it. So I'll let you guys handle the rest, but make sure you don't forget your units. Okay, the last one, page 32 in your guys' book. Just kind of bouncing all over the place, doing a lot of different things. So we have a differential equation here. A differential equation is an equation that has a derivative in it. We've been looking at them all day, actually, on this video. Just finally naming it as such. On the axis below, sketch a slope field for the given differential equation at the 8 points indicated. So I'm assuming they're talking about 1, 2, 3, 4, 5, 6, 7, 8. So how do you do that? Well, let's pick a point. Let's do -1, 1, this point up here on the top left. So basically, if I want to find out what the slope is at that point, the derivative is a formula that gives me the slope. So what I'm going to do is I'm going to plug in the point -1, 1 for x and y. Okay, so let's go ahead and do that. So y is +1 and x is -1. That's -2. So the slope at that point would be -2. Now since it's negative, that means it slopes down. And so I would say a slope of 1 looks like a 45-degree angle. So a slope of 2 is going to be steeper than that. So I would say that would be what that looks like. And you're just going to repeat that process at all 8 of these points. Don't forget, if you have a 0 in the top of your fraction, it's a flat line. If you have a 0 in the bottom, you can draw a vertical line if you want, indicating that the slope is undefined at that point. Okay, I'll let you guys do the rest of those. As for the next part of this question, I'm not going to do it for you, but I will do an example like it. I want you guys to do this. Find the particular solution, y equals f of x. So let's stop there and understand the vocabulary. The particular solution, y equals f of x, that means if this is the derivative of some function, we'll call it y or f of x. If this is that function's derivative, what was the original function? In other words, we want to work backwards to find out what it was before the derivative was taken. Every time you do that, you're going to end up with a constant of integration. And the way that you find out what that is you use initial condition. I'll use less fancy language. Every time so basically to find your function, you need to integrate this. And when you do that, you're going to get a plus c. And to find out what your plus c is you need to plug in that number there. So after we get that, they also ask us to state this function's domain. Okay. In other words, what are the possible values of x for this particular function? Okay. So I'll keep the same idea, but I'm going to change the equation a little bit. Okay, so I'm looking for a particular solution for this function, let's say, and I don't know, let's go ahead and just, let's go ahead and say that f of 3 is equal to, how's about negative, I guess we'll just say -1. Okay, so I want to find the particular solution. So what I need to do then is I need to separate the variables. So what I'm going to do is I'm going to multiply the dx over here to this side. So that gets rid of that, right? And then for this guy, I want to put this one over here with the y, so I'm going to divide both sides by 2y plus 4. And so this ends up looking like this. So multiply both sides by dx, divide both sides by the top, and that way I've got the y's on one side and the x's on the other. And then we're going to integrate that. Now that there, I usually on how they grade it is worth 1 point. So just separating your variables is usually worth 1 point. But now we actually have to do the integration. I'll show the work for the first one, but for the second one, I'm just going to put the answer. Okay. So this would be this is a logarithmic expression here. So I'm going to say that u is equal to 2y plus 4. The derivative of u with respect to y in this case is 2, which means that du over 2 equals dy. And therefore, I'm going to rewrite this whole expression as follows. And now the integral of 1 over u is ln of the absolute value of u. And that 2 there just becomes a half power in the front. Okay? And once again, when you're done doing your integration, you always want to put back what the problem originally was. So there's that. Okay? So I did that side. Now, you would do technically, you would have to go through and do the same thing on this other side, 1 over x minus 3. I'm going to skip all that work though, and I'm just going to show you what you would get. You would get, not much of a surprise honestly, ln of x minus 3 plus c. Okay? So there's the general solution, but the problem is that they want it as a function y equals f of x. In other words, they want the y by itself. They don't want the y inside of the function. They don't want it implicit. But before I actually start finding that problem, what I'm going to do is I want to find out what c is. Because what I'm looking at right now is an implicit function that's a general solution, but I want to get a particular solution, which means I need to find my c by plugging in the values that they give me there. So I'm going to plug in 3 for x and -1 for y. Now you guys may be thinking, oh, this is a really ugly problem. And it is. It's tough, but it's a great review problem. I'll tell you, these types of questions are extremely popular. And what's cool is they're pretty cookie cutter. And what I mean by that is, like, if you know how to do one, you kind of know how to do them all. So even though it's a lot of work, it's definitely worth your time learning how to do these, because they've had this type of question on the FRQs for years. And so if you practice a lot, you're guaranteeing yourself some good points here. So don't give up on it because it's hard. It's worth the investment of your time. So I'm going to go ahead and plug in -1 for y. And I'm going to go ahead and plug in, what did I say, 3? I'm going to have to change that because otherwise this whole problem is going to fall apart and it won't work. So, darn, I tried to be smart and I wasn't. Foolish man. All right, I'm going to change this to f of 4. Sorry about that. Okay, ln of the absolute value of 4 minus 3 plus c. If I left that as 3, I would have gotten 0, and logs can't have 0 in there, so that would be undefined and everything would die at that point. But logs can have 1, so let's go ahead and simplify this a little bit. -2 plus 4 is 2, and the absolute value of 2 is 2, so we have ln of 2. Over here we have ln of 1 plus c. ln of 1 is just 0, so we can get rid of that. And now what we have is we have 1/2 ln of 2. Now, you can leave your answer like this if you want to, but I'm going to do a little log trick. Anytime your log has something being multiplied in the front, you can make that a power. And 2 to the half power just means the square root of 2. So I'm going to write my c like that. Not necessarily a super important thing to do, but not a bad thing either. All right, so now I've got my expression, or my c value. So I'm going to go back up here to my general solution, and now I can replace the c with ln of the square root of 2. Okay? Okay. Now what are we going to do? Well, now we want to start getting that y by itself, okay? Because remember, we want to get it to be y equals something. So the first thing I'm going to do is multiply everything by 2. Okay, to get rid of that half. The next thing I'm going to do is I'm going to use a rule. I'm going to use a log rule again. And I'm going to move this as a power on that x minus 3. So that's going to end up being ln of x minus 3 squared. And I don't need the absolute value bars anymore because anytime you square something, it automatically becomes a positive. And then here, if I square a 2, I end up with just 2. I'm going to use another log rule here. And they don't always get this crazy with the log rules, so this is kind of a cool problem to see. I think you might have a little bit of the log rules going on in yours, but I'm going to use another log rule that says that anytime you have two logs that are being added together, you can write them as one logarithm where this piece and this piece are being multiplied together. The next thing I'm going to do is I'm going to exponentiate both sides. What that means is whatever my base for ln is, which in this case is e, right? We're going to make that base for each side. And the e cancels the ln out. And so here's what we're left with then. All right. Now, since we have an absolute value expression here, that means that 2y plus 4 can be equal to a positive 2x minus 3 squared, or 2y plus 4 can be equal to a negative 2x minus 3 squared. Okay, so we have two possibilities here since that's an absolute value expression. So I'm going to subtract 4 on both sides here. Remember, we're trying to get that y by itself. And then I'm going to divide everything by 2. So here's one possible solution, particular solution. Same thing over here, I'm going to minus 4 on both sides. And divide by 2. And here's my other possible particular solution. Oops, it's not plus, it's minus. I forgot to divide this 4 here by 2, so let me back up. This one should have been 2 as well. So these two expressions are identical. There's only one difference. On this one, there's a positive in the front, and on this one, there's a negative. And now we got to ask ourselves, which one is it? It can't be both. Okay. The way you could tell which one it is which one of these works with the problem that they gave us. So remember how I told you that f of 4 has to come out to equal negative 1? Which one of these would give us the correct answer? Let's see. If I were to plug in 4 here, 4 take away 3 is 1, and 1 squared is 1. 1 take away 2 is negative 1. So this one works. If I tried plugging in 4 and negative 1 over here, it probably won't work. Let's see. 4 minus 3 is 1. 1 squared is 1, but there's a negative, so it's negative 1 take away 2, which is negative 3. This one does not work. So this is our problem that we wanted.